Hey, so welcome everyone to our second Tuesday presentation, March 2024. This presentation is on a new color library that we're introducing called ChromaSpot, and you'll be able to sign up to get more information as it becomes available on the link that I shared with you in the chat area. So if you go to the chat area of Zoom, you'll see a link there. This will allow you to sign up to be up to date on the new availability of our ChromaChecker Spot solution. So without further ado, like always, if you guys have questions, please feel free to put them in the chat and Beth will funnel them to me. And when we talk about trying to describe colors for other people, oftentimes people either want to describe it in an RGB value or a CMYK value. I remember the first time I was working with M&M Mars, and my question for them was, what colors is the blue M&M? And their answer back was, it was like 80 cyan and 40 magenta. And I asked them, on what device is it 80 cyan, 40 magenta? And they looked at me like I was from Mars. And what they were not realizing was that when you give a RGB or CMYK build of percentages, it's totally dependent on the RGB or CMYK gamut that you're talking about. So, for instance, you say 100% red. In a View RGB color space, it's going to look like the one on the left. On an Adobe RGB color space, it's going to look like the one in the middle. And on a ProPhoto RGB color space, it's going to look like the one on the right. So the same RGB value is three different colors. And in the same way, the same CMYK value on three different CMYK devices can be very different. And in this case, I had to print this 80 cyan, 40 magenta on three different printers at the print location that we were at to show her that 80 cyan, 40 magenta on three different printers is three entirely different colors. And we can't, if you want to have consistency on the color, you need to define the color in a device independent color space. RGB and CMYK are device dependent color spaces. So this is where lab comes in, LAB color space. You've probably heard of this. It's the universal color translator. Lab represents the gamut of the human eye. So every color that we can see has a lab definition. And the key with lab is it's illuminant dependent. So the same lab color, the same lab number for different illuminants will result in a different color. So in this case, I've got a D50 illuminant on the left with the same lab value as a D65 illuminant on the right with the same lab value. And you can see visually, it's a different color. So, and there's more that goes into lab. It's not just illuminant, but it's also the angle of the observer. So as good as lab is in that it's device independent, it is dependent on the lighting that you're using to look at that color. So the fact is, we have all sorts of lighting that we have to deal with, and we don't want colors that are lighting dependent. So this is where spectral data comes in. And if you notice, it only takes three numbers to define a lab color. But when we move into spectral data is the granddaddy of defining a color, in that it uses 32 numbers to define one color. And from spectral data, you can interpret LEB data in any illuminant. You can interpret CMYK in any CMYK device that you have a profile, an ICC profile for. And of course, you can do the same with RGB. And here I have a screenshot from our ChromaChecker capture. I actually measured this a second ago. It's the Ritz red on the box here. And automatically ChromaChecker comes up that it's signal red, and it plots it in the color space. And you can see the LAB values in the middle. And then over on the right, because my ChromaChecker default is set for an HP indigo, it gives me the CMYK breakdown for an HP indigo of 0, 100, 90, and 18 will make that red. And it's a 1.78 delta E. So it's right on the edge of the color space, but it can be made. And if I want to render that color in my monitor in Adobe RGB, I would use 170 red, 16 green, and 44 blue. And if I wanted sRGB, there's a hex number for it. So in this way, spectral data is ideally what you want to use to define all your colors, and any color library that you use, ideally you want it in a spectral format. In addition, spectral gives you the ability to understand the volatility of that color under different lighting conditions. So it's called color inconstancy. And you'll see over on the right now, I changed my tab from the ICC tab, which gave me the indigo and the Adobe RGB values. I clicked on the color inconstancy index, and it shows me the volatility of this signal red color under A is incandescent lighting, so kind of a yellowish lighting. And you can see it's moving by 10 delta E. Over on the right, you see F2, F7, F11. These are different fluorescent standards. And you can see how much that signal red is changing under different fluorescent lights. And if you have a measurement device like an i1 or a Miro one that allows you to actually, through ChromaChecker capture, measure whatever light you're working in, you can add a custom illuminant on this tab to show you what effect this signal red will have under, let's say, a given LED light that you're needing to design it for. And more retail locations are going in with different types of LED lights that can greatly change the perception of the color. And having the spectral definition with this color inconstancy index gives you an alert of how much this color is going to change when you put it in a different environment. So this little basic color overview I'm trying to give you is hoping to drive you to the idea that whatever color library you use, ideally you want the data to be in spectral form. Now, traditionally, we've used physical samples from swatch books or fan books to look at colors and try to communicate the color that I'm wanting. And when we're dealing with a physical sample, there's a lot of variables that come into it. Not only they're subject to wear and tear and aging, but duplicating the sample over time can be quite challenging, and it's very dependent on the substrate. So if the sample you have is on a certain substrate that you can't get for your fabric printer, it's going to be really hard to reproduce that color. So as much as a physical sample is useful, and physical samples have been used for many years. One of the first documented color charts was produced in 1692, 270 years before the original Pantone color guide. And so defining colors with charts has been going on a very long time. And it's nothing new, but it's important to be able to communicate color using some sort of language that helps everyone know what color you're wanting to get. Pantone obviously is a color specification that people have used forever, and there's been a number of derivatives of the Pantone library through the years, and it currently keeps getting derived because there's certain colorants that Pantone can't use anymore to reproduce the colors, which means the colors in the existing library have changed. So even though it's the same number, the color that was defined, let's say 3 years ago, is different from today. And so even for the same number, you don't have a continuity of that color being the same color, which is a problem. One of many related to some of these other third-party library systems. So let's talk about the other problems. And it's not just related to Pantone. Other companies that have swatch book type libraries also have these types of issues, such as the library is substrate dependent. Help me understand how, if I've got a Pantone value, I'll just pick on Pantone for a minute, let's say 185, and just from memory, most people know that's a red, kind of like my Ritz red, that 185 has a certain color when printed on coated stock, and a totally different color when printed on uncoated stock, and a totally different color when printed on fabric. And it's like, well, wait a minute. Is it 185 or not? 185, there's multiple shades of 185 based on the substrate that you're printing on. How does that help color communication? Ideally, the color name should be the same no matter the application, no matter the substrate that it's going on. So that's one huge limitation that I see in the industry. Another one I already referred to, the swatch books are not especially accurate to what people's expectations are. I've actually done research that I've published with Pantone books that I have going back 20 years and these Pantone books are pristine, they've never been used. And there's certain colors in the Pantone book that are 10 delta E different from the same number defined 20 years ago from today. And so that's a problem. And of course, you have to purchase these swatches and fan guides. And the colors in the library are not necessarily uniform to one another or evenly distributed. And of course, if I ask you what Pantone, let's say 421 is, I bet there's very few people on the planet that could actually tell me what 421 is, because the number doesn't really have a rhyme or reason of where it is in the color space. So you've got to actually go look to see what you're trying to reproduce. You can't even say, oh, that's in the red family or the green family. You have no idea. And then, as I mentioned, many PMS colors have to change due to the old colorants are no longer available. And so they have to use new colorants. And so for the same number, the color changes, which can cause a nightmare if that's your brand color. And typically only lab colors are digitally distributed. And so, and of course, if you want spectral data, you've got to pay a license fee for every time you access that spectral data. So there's a lot of problems with current solutions, which doesn't make specifying color easy. So what if we had a new color library for the market where the colors are substrate independent and lighting independent, and you can generate your own swatches and fan guides on your own accurate printer? The colors are uniformly spaced within the color space. And with limited color knowledge, you can recognize where that color is in the color space, meaning is it a red, is it a neutral, is it a green, based on the color code of the name. Wouldn't that be nice? And wouldn't it be nice if users can propose their own names for colors using natural language, such as royal blue and signal red and sky blue and things like that? So not only does it have a code name, but it has a natural name, which many people prefer over some cryptic number or code. And of course, where the spectral data is free and easy to access. Well, welcome to ChromaSpot. ChromaSpot is a project that we've had going on in the background. We've actually started an independent company to develop ChromaSpot. And you can find out more about it at chromaspot.org. And the key is it's a universal color library for the industry. without any fees. It's going to have an SDK where third parties can plug into it. And as long as they're not charging for it, it's available for any third party to access. It's all spectral, and all the data is, all the colors are essentially available from ink manufacturers and pigment manufacturers for the whole supply chain. We are going to be distributing this library within a few weeks in both CXF and ACS, so Adobe Color Swatch formats, to make the library very accessible and easy for people to use. And the naming convention is what I think to be very simple, in that if you understand LAB, where L is the, here, use my ChromaSpot diagram here. So I'm sharing with you our ChromaSpot sphere, which will be available for our early adopters and our people who want to help fund this project, where L is the lightness. So the North Pole of this is pure white, the South Pole is pure black. So the gray ramp runs through the core of this object. You have the hue around the circumference of the object, and as you move from the inside out, you increase the chroma, or the saturation. So in this way, if you understand these basic concepts, then you'll understand the concept of the naming convention of ChromaSpot. So essentially what we've done is we've broken up the hue wheel into the greens, the blues, the violets, the reds, the yellows, and so in the greens, it ranges from G1 to G6. So G1 is more on the yellow, G6 is more on the blue. And then the blues range from B1 through B6. So each of these colors, if you will, are slotted with numbers. And then in the same way, we have chroma going from essentially 0, which is neutral, out to, in some cases, 9, which is a highly chromatic or highly saturated, a very vivid color. And then, of course, the last number is the L star, which is the lightness in terms of how dark or too light, how light it is. So if we just instantly apply this to some actual colors. So if it's a neutral, so a gray neutral, where the chroma is less than 0.5, then we name it with an N for neutral, and an N36 would be 36 L stars. So kind of a darker gray would be N36. Whereas a color would be a 1, which specifies the chroma, which 1 would be very pale or neutral. So a 1Y would be a pale yellow. And in the 1 slot, which you see over on the right, and then the 78 would be the lightness. So it instantly tells you that this 1Y1.78 is a light pale yellow. Whereas something like an 8 is again the chroma. So immediately 8 means very saturated. R, you're in the red range. And then 3, you're in the R3 red range. And 52 is the L star, which is right around 50%. So this 8R3 red would be right around here in my color space. Very saturated and kind of in the mid-range. And if I just quit out of this slide for a second, I'm going to pop to the website. And when I go to the website, you'll see in ChromaSpot, here are my ranges of colors. So here's my Y1 through Y6. And if I click on that Y1 and the neutral and click in here, it will then show up on my list that you see here. And if I click on any one of these, like this one's desert sand, you can see here's the spectral curve for it. It's automatically calculating the LAB value for it. It's calculating the CMYK for my HP Indigo and the RGB value for my Adobe RGB. If I were to click over here on the, let's say on the reds, Here's my reds. And by the way, I can go ahead change the view here, and you can see my 8 was it like 8453. You see there's that red here, that nice brilliant red, and you can see all the values related to that red. So I can add that red to my scratch pad if I want. And you see some of these have automatic names. So like this one's a cherry red. And if I click here, you can see what that cherry looks like. Cherry red looks like. Here's an orange red. Here's a fire engine red. So some of these not only have the code names, but they have natural English names. And by the way, this is translatable. So we've got it right now, I think, in 8 different languages. So Spanish, Italian, Polish, German. It would be comparable to what fire engine red is in those languages, so that, again, people understand, oh, that's what that color is. And we have a procedure where people can name colors, give colors names, and it goes through essentially a committee of approval. And if it makes sense to people, we'll add a lot more common language names to these colors so that they're more descriptive, and you don't necessarily have to figure out the code in terms of what that number is. The other thing to know here is that as I click on some of these colors, like let's say a deep purple here, depending upon my, here with this purple, you can see my HP indigo, the best it's going to reproduce this purple is the 6.5 delta E. It's showing me this purple is out of gamut of what my printer is actually capable of producing. So in this way, I might not want to choose this color. In fact, with this library, you'll have the ability to choose multiple printing devices. So let's say I've got an indigo, a Colorado, and a offset press printing to Grackle. I can say, only show me the colors in the library that are capable of being rendered on those 3 devices in CMYK color space. And ChromaSpot can go in and limit the library to give you only selections that are available on all 3 of those printers. Now, if you were only printing on one, you of course could say, hey, just show me all the colors in gamut of the indigo, and it'll give you that. So very flexible, very up to date in terms of the technology to show you the colors that are relevant to how you're going to use them and communicate these colors across your network of application. I'm kind of surprised no questions have come in. We have a lot of people in the audience, but I guess nothing's come in yet. So if you guys have questions, feel free. This slide deck is, of course, going to be available for you if you want to access it. I'll make it available up on the website where the recording of this presentation will be. And again, a little more detail about the naming of the ChromaSpot. And just reinforcing, here's the whole concept of substrate dependent versus substrate independent. With other libraries, you've got a different color for coded versus uncoded. With our library, it's the same color, whether it's on plastic, on different types of paper, on different types of fabric, doesn't matter. If you're asking for signal red at 8R344, there's one color. There's no interpretation. There's one color for that. Now, whether or not that color is capable of being rendered on uncoated paper, that's a second issue. But the definition of the color is the same. So here are the key benefits of the ChromaSpot library. Substrate independent, simple coding based on measurements of reproducible, printable, and paintable samples, optimized for homogeneity, ability to get additional reproducibility information, designed by designers. Designers actually came up with this, compliant with all industry standards, and does take into consideration of things like fluorescence and metamerisms.
Dave,
Yes, there's a question.
we have a question. Will this be a subset of the color inspector within ChromaChecker, or is this a completely separate account?
Okay, great question. So ChromaSpot is a separate company, separate technology, but it is licensed to ChromaChecker, so it will be available within ChromaChecker Color Inspector, and you'll have full access to it. So you can use it without ChromaChecker. If you have ChromaChecker, you will have full access to it. Yes. Other questions? So with the ChromaSpot,
I'm gonna repost that link because other people are not seeing it.
okay, great. So so there's a question: a system to be used to generate a specific physical color standard. So essentially, here's the deal: these colors have true spectral definitions. Now, if I want to make a custom swatch book on my Epson proofer, what I could do is I can take a target like you see on the screen here, which has all the colors in the ChromaSpot library. And I print this on my Epson printer. And I measure it in, ideally with an automated measurement device like Miro 9 or my ISIS over here or my i1IO. And I measure this target. You could do it obviously with an i1 or even a NIX if you wanted to take the time, but you measure that value in, and it will compare what the actual value is of that color versus the Epson's interpretation of that color. And even though the color library is going directly through the Epson profile, so it's going spectral LEB to the CMYK of the Epson profile, some colors will be within a delta E or two, but some colors will not, depending upon how old that profile is. And if you've been with us, like for last week with our color match technology, where last month, excuse me, I demonstrated real time on my cheap HP laser printer how I could take a color sample and measure it, and ChromaChecker automatically iterates the color match on my printer within, I think last month it did it within 2 iterations. Well, it can do that with the ChromaSpot library for my Epson. I wouldn't necessarily try to do the ChromaSpot library on my HP because the within sheet variation on the HP LaserJet that I have here is like 3 delta E. So I'm not sure I'd spend my time trying to tweak my ChromaSpot library on an HP laser printer that's very inaccurate. But on my Epson proofer, absolutely I would do it. So in this way, you take this library, you print it, you measure it in. ChromaChecker checks how the Epson is rendering those colors versus what the true definition is of those colors. And it'll go in and make a lookup table to fix that difference that I could then output again. And on the second time, it won't have to iterate as many values, but it will iterate more. It makes a new lookup table for the printer, and you come up. And so hopefully within 3 times, you now have your Epson dialed in, or your proofer dialed in to make the ChromaSpot library of 3,300 colors. And in ChromaChecker, you have the ability to lay out a swatch book layout. So you could actually print the swatch book layout out on your printer, and then through some sort of die cutting or however you want to fashion it, you build your own swatch book, and it's to the overall reference of the color of the library, so that your Epson, if you iterate the data on your Epson versus my Epson, the two will theoretically match really, really close. Of course, depending upon your substrate, but as long as you're using a substrate that allows the nice gamut of the Epson to happen, you'll have it working. So in this way, you can make custom swatches for this library on accurate type printing devices. And that's for the full library, assuming that the full library is in the full gamut of the Epson. but you can also do it specific to your HP Indigo or your Canon Arizona or whatever printer you're running on. So very
Hi, Dave.
flexible in terms of how
We
this is done.
we have a few questions.
Yes.
First question is ink formulas for Flexo.
Sure. Yeah, if you've got a CMYK profile that represents your flexo condition, you can absolutely load that into this software, and it'll tell you what the CMYK values are for that color.
Okay, next one. Are you exhibiting at Drupa?
Yes, we will be at Drupa. We're going to be in the use norm light booth booth at Drupa, and I'd love to meet with you if you're coming out there. Christoph will actually be there the first half of the show, and I'll be there the last half of the show. So we will have representation at Drupa.
Okay, next question. If a global marketing company selects a color from ChromaSpot, how is that color going to be translated throughout all print partners and devices? Basically, where would the client select their brand colors from?
Okay, so if they, let's say you say, okay, I want to use a ChromaSpot library as my brand value, or ChromaSpot colors my brand value, you can essentially use it as a name color and distribute it to your supply chain. And as time goes on, we've got an API for the library on the cloud that third parties will be able to access, so that if I'm using, we've had a number of talks with some RIP companies that are really interested in working with us on this, so that in the short term, you just take whichever M condition of the CXF data of the library, give it to your suppliers, they load it on the RIP, and then when you send your PDF with your brand color with the ChromaSpot name on it through to the RIP says, oh, this is a ChromaSpot color. It knows for this printer to use this CMYK combination to render that color on the printer.
Okay, that may tie in with this question. How are the M0, 1, or 2 conditions applied? Did you just answer that?
What sort of? So the data in the library, in the CXF library, is all three. So the CXF will include M0, M1, and M2. And if people needed a separate M0, M1, and M2 CXF for the ChromaSpot library, that's available as well. Some applications are smart enough to understand that in one CXF you can have all three M conditions. Some are not that intelligent, so you have to have a different library for each M condition, but we'll make both available. As well as the Adobe ASE file, which is the Adobe Swatch Exchange, so you'll be able to load it into Adobe apps and see the color in Adobe apps.
And then these questions were a little bit before you broke, but how can substrate not impact color?
Oh, substrate absolutely impacts color. So, but remember, if there's a global definition of what, let's say, 8R450 is, so I know what that is. So as long as the substrate that I'm putting in my printer is capable of rendering that color, we'll render that color the same on 10 different substrates. Because the definition of the color is the color, independent of the substrate. The substrate absolutely influences how that color is going to render, but by using our color match function in ChromaChecker, it'll iterate out the influence of the substrate so that it matches the original value. Hopefully that makes sense.
Next question.
Go ahead.
If it doesn't, well, I'll ask them to please ask it for clarification in the chat. If we use a Fiery RIP in front of the Epson, does the lookup integrate with the Fiery?
Yeah, essentially, we export a CXF, which Fiery can import. So today it's compatible. Yes.
Okay. So the next question is, can I import the color spot library in my RIP? So that's it. Is it available for all RIPs or?
So CXF is color exchange format. It's a universal exchange format for color libraries such as ChromaSpot, and most RIPs support the CXF file format. So if they don't support the CXF file format, I know we'll be able to export the ChromaSpot in some other different formats, but CXF is kind of it's a color exchange format. So it's kind of the one we're trying to get everyone to point to. But if someone wanted a CGATS version of the ChromaSpot library, I'm sure it wouldn't be a problem for us to export it as like a CGATS.
Okay, that's all the questions at this moment.
Great questions, guys. Keep them coming if you have more. So here's a
Oh,
look
wait,
at what the
one
ChromaSpot
more.
library looks like in a three-dimensional color space. So no two colors are, I think, closer than like 1.5 delta E, and no two are more than 4. So you don't have colors right on top of one another. They're nicely spaced.
Dave,
Yeah.
one more question. It seems then that in order to achieve the same spot color printed via Flexo in one station, you'd need an ink formula for each, a different formula for each to be clear.
Okay. So let's talk about Flexo. So in Flexo, you can define the color from the ChromaSpot library and have a spot color formulated to match that reference. So that's one way. So then you could actually do a spot for it. And with ChromaSpot, you could ensure that that spot is correct by checking it. Or if you were doing it on Flexo and it was a brand color, yeah, I probably wouldn't try to define it as a well, you can define it as a CMYK build, but obviously it becomes a lot more volatile in a CMYK build. So but with a good profile, you can reduce the amount of 3-color CMY in it, put more black in it, so you get a more stable CMYK build, or even it's not limited to just CMYK. You could do a 7-color build of these colors as well. In fact, we'll have our library, a custom subset of the library for Grackle orange, green, violet, which is the ECG or extended color gamut version of this library.
So another question for designers, could this be integrated with ASE, which they would be more likely to use?
Absolutely. ASE will definitely be one of the first, will be original file format for these colors. So we have the ASE library today. And we'll make it available to our beta users and for our first responders. Okay. So here's some of the subsets that we'll have. We'll have the whole ISO 15339 data sets, so the CRPC 1 through CRPC 7, including Grackle coded and Grackle uncoded, which you see here on the right. We'll also have Adobe RGB and a P3 display, and we'll have, as I mentioned, an ECG. We'll have an Indigo. We'll have an Arizona. So we'll have some default subset libraries specific for certain types of printing devices on a given substrate. But then, of course, you'll be able to make your own subsets based on the printing devices and the substrates that you're printing on, so that you'll be able to make a library for your customers showing them these are the colors that our printers on our substrates are capable of being produced, so that over time you can reproduce the colors that they're asking for. And by you building a library specific for your printing devices, it will help that bond with that customer to know that, hey, they know if they are using you as a printer and your printing devices, that they'll get the same color every time because you're using process control and ChromaSpot, and you know what you're doing in terms of matching colors. So it's all about helping printers be more profitable and communicate color more effectively. So here's a slide about the homogeneity. And so the availability, we're looking at April 1st available, so less than 2 weeks away. As I mentioned, we'll be distributing the CXF and the ASEs for the different M conditions. So people can use the ASE in the Adobe Creative Suite. They can use the CXF in virtually any RIP. We'll have default subset libraries. You'll have the ability to build your own accurate fan book, but for that, you're going to need a third-party software program such as ChromaChecker to build your fan book. We will allow brands to add their own colors to the ChromaSpot library. So it's not just going to be ChromaSpot colors. There'll be a allocation for brand companies to put their colors into the ChromaSpot library, and it will only be editable by that brand. So we have a mechanism in place that the brand owner has essentially a password, so that should they ever update their brand library, they can do it through their portal into their ChromaSpot. But the concept is, we'd like to see all brand companies put their brand colors into the ChromaSpot library, which can be freely distributed to everyone. And ideally, all the RIPs and all the color servers will build the API in to access the library, so they'll always have the right version of the right color at the right time. So we're very excited about this new development. As I mentioned, please register and sign up using the link that's in the Zoom chat area, and you will be updated as we progress with releasing everything to the public. We do have beta users today. If you want to be a beta user, please reach out to me, David at ChromaChecker.com, and depending upon your use, we might give you a beta license so you can start testing it and giving us input. But the rest of you, you'll have access to it on April 1st.
People are excited.
Any other questions? All right, well, thanks everyone for attending. I hope you found this useful, and if there's additional improvements that you have in terms of things we haven't thought of or other things that we could do with this, we're all ears. As I've said, this is a independent project, ChromaSpot.org. We are going to be doing some crowd fundraising for this. And in terms of the crowd fundraising, we'll have a minimum amount for donation, but the donation, the initial people for the donations will get this really nice ChromaSpot sphere, which is, I don't know if you can tell, but it's made out of cardboard, and it's white cardboard, and then it has all the naming numbers on it. So it's really sturdy. You could actually play baseball with it. It's so solid. And so if you'll get information if you sign up about the crowdfunding, which would allow you to get your own ChromaSpot sphere, because we're not looking at making money with this technology. We feel like the industry needs something like this to help communicate color more effectively, and hence we've taken on this project. So hope you wish us luck. Hope you support us in this endeavor, and sign up to learn more about it. With the links that we provided.
I have a quick question.
Yeah, go ahead. Question. Can you write the question on the chat?
Sorry, could I muted? I thought it was background noise. Can you unmute, Larry?
Okay. There's going to be a lot of background noise. You said that you print a lab value in different light spectrals, like MO, M1, that they would look different. Do they look different if you're looking at them under the right lighting? I know they're going to look different if you look at them under one particular lighting, but if you look at D65 in a D65 direct sunlight, or if you, will it look the same then?
Okay, what I meant to say was that the same lab value, so what you see up on the screen here, so the same lab value for different illuminant conditions will give you a different color. So you see on the left, a lab value of 54, 90, 63 is kind of a more saturated red than the lab value of the same number, 54, 90, 63 for D65 is a darker, more, let's say, less vivid version of the red. So when we're dealing with lab numbers, we need to be conscious that the lab, when someone gives you a lab value, you need to ask them, for what illuminant and observer angle is this for? Because without that, you don't actually know what the color is. Because if someone gave you a 54, 90, 63, and their intent was D65, 10, you're not going to reproduce that color correctly. So this is more just helping people understand that a lab number is illuminant dependent and observer angle dependent, as opposed to a spectral value, which is illuminant independent. Is that answering your question, Larry?
Yes, so you're saying that the jaws will look the same under all three lightings printed on the same piece of substrate?
So in terms of, can you rephrase that question?
So if I print something in D50, because we print police decals, so what's bad is when they pull into the shade, it's a different color than when they're in the sun.
Absolutely.
Does y'all correct that problem?
So in terms of correcting the problem, ChromaChecker will show you the volatility of the color using the color and constancy index. So you'll be able to see how much that color will change based on different illuminants. It can also allow you to design, let's say, for D50 and make it match in a different lighting environment. You can do that with ChromaChecker as well, so that if you want, let's say, this color of 54, 90, 63 and D50, but you have to manufacture it with an illuminant of an LED light source that's totally different than D50, ChromaChecker can help you reproduce that color in this different illuminant so the visual color matches, even though the LEB value will be different. So we're all about matching colors between different color specifications. ChromaChecker gives you today, this is an advanced capability that most of our users don't even know we do. We have the ability to create a custom color specification, which represents the illuminant and the observer angle. And by doing this, you can make a custom condition that you can then match from one color to another. And like I said, this is more of an advanced topic, but it's all possible with our technology. And we'll have trainings and sessions on this as we go forward in the new year. This has been a pretty topical, a pretty relevant topic. Came up during our color conference last month, and we talked about it slightly, but I think we'll have a whole session dedicated to this topic at our color conference next year, because it's a hot issue of matching color between different illuminance. So with that, I didn't see anything else come up on the chat. So again, thank you all for attending. Hope you found it useful, and please sign up for updates about our ChromaSpot technology. Have a great day.